In this video, we're going to talk about how to draw exponential functions that have had that transformation done. And so it's with exponential functions and their transformations, it's really important that you understand what that parent function would have looked like, because depending on what the base is, the parent function can kind of change. So this one is one where it's going to be really helpful to look at these examples, even though I know this is kind of a lot of information for one section of notes. In this one, our parent function is 2 to the x. So we have that base of 2. And that's important to note. And then there are a few key things that we want to talk about when we are looking at these. So for example, in this one, I want to make note of the fact that my y-intercept is going to be at 0, 1. And then for the parent function. And then the transformations, hold on, I'm just double checking on my notes. Oh, and then I want to also make sure I know a couple points on this parent function. So for 2 to the x power, when x is 1, that's 2 to the first power, which means I have a point at 1, 2. And 2 to the x power, when x is 2, that would mean 2 squared, means I have a point at 2, 4. So those 3 points are going to help me guide my graph. So I want to go ahead and plot those 3 points of this parent function. So I have my y-intercept, and this is probably not going to go very well in a video, but I'm going to do my best. So I have my y-intercept, I have a point at 1, 2, and then I have a point at 2, 4. And I'm going to think about the transformations that are happening and how those are going to affect those 3 points. So the only transformation in this function is a translation or a vertical shift where my graph is going up 3. So each of these 3 points is going up 3. That means my y-intercept, or not my y-intercept, I'm so sorry. My y-intercept is going up 3, but my asymptote is also moving up 3. So exponential functions normally have an asymptote here at y equals 0. For this graph, it's getting moved up to 3. I'm going to draw that in as a dotted line, and then I'm just going to count up 3. I wish graphs were easier to do on here, guys, sorry. So I'm just going to move each point 1, 2, 3, and 1, 2, 3. I think I did this one in the wrong spot. I went up 4, so right there. So let's erase that other one. Okay. So now I can roughly draw in this exponential curve going through those 3 points, but I want those 3 points to be relatively clearly labeled. And like I said, it's very hard to do with this keypad, but on your graph, please have them labeled. And please reference the notes key in Google Classroom so that you can see how I clearly labeled those points when I had a better way of drawing. In example 2, our parent function is y equals 3 to the x. So this parent function has a point, a y-intercept at 0, 1, and we're looking at the function of 3 to the x. So when x is 1, that's 3 to the first power, y is 3. When x is 2, that's 3 to the second power, 3 squared, so y is 9. So we are going to use these 3 points to base our graph off of. So I have a point at 0, 1, I have a point at 1, 3, and I have a point at 2, 9. So my graph would be going up like this. Well, the transformations to this graph are a reflection, and I have a horizontal shift in the positive 1 direction, so I'm moving it 1 that way. So all of my points are getting reflected down. I'm going to show that first because technically we're still following the order of operations. So multiplication before addition and subtraction. And that reflection is basically multiplying this graph by -1. So this point that was up here at +1 shifts down to -1. 1 +3 goes to 1 -3. And then 2 +9 goes to 2 -9. There's also a horizontal shift, so each of these points gets shifted over 1. And now I'm ready to draw in that curve. It's coming in along the asymptote and then growing like that. In example 3, my parent function is y equals 4 to the x. So because my base is 4, this graph is growing pretty quickly. We are actually only going to be able to graph 2 points and be on this given graph here. But we have our y-intercept, and for this parent function, when x is 1, y is 4, and if I were to look at when x is 2, that would be 4 squared, that would be 16, which is, like I said, going to be off this graph. We're not going to bother with that. So we're going to base our graph off of these 2 points. Excuse me. So we have a point at 0, 1 and at 1, 4. So we have this exponential growth. The transformations are a horizontal shift. I'm going to abbreviate. So it's going horizontally in the positive direction, 3, because of this subtraction in the exponent. And we have a vertical shift going up 2. So each of these 2 points is going to go over 3, 1, 2, 3, and up 2, and over 3, 1, 2, 3, and up 2. Now, anytime I have a vertical shift, that also adjusts my asymptote. So rather than having an asymptote at 0, it's now up at 2. And so since that has moved, I want to draw that in. It's also going to make it easier to draw that exponential curve there. So your curve is coming across close to that asymptote, and then it's curving up to go through those 2 points. The only transformation in example 4 is a dilation of 1/2. So we're going to finally get to look at how a dilation affects this graph. But the parent function here is 2 to the x. So this parent function has a y-intercept of 1, and we're going to look at a couple x values. So when x is 1, y is 2, because 2 to the first power is 2. When x is 2, that's 2 to the second power, so we have 2, 4. I'm going to do another, so when x is 3, that's 2 to the third power, which is 8. And again, like I said, the only transformation is a dilation of 1/2. So this is half. This is going to shrink our graph. We're going to take each y value and divide it in half. So we're going to graph these 4 original points, 0, 1, 1, 2, 2, 4, and 3, 8. My x values aren't changing, but each y value is getting multiplied by 1/2 or cut in half. So instead of having a y value of 1, that gets bumped down to 1/2. Instead of having a y value of 2, that goes down to 1. 4 times 1/2, or cut in half, is 2. And then 8 cut in half goes down to 4. So my asymptote hasn't changed. I didn't have any vertical shifts, but now my graph is not growing as quickly. So that's my new graph there. This one, there's another dilation. There is also a horizontal shift, but my base, my parent function, is 2 to the x. So the same parent function that I had here. So again, intercept of 0, 1, and this parent function leads me to the points 1, 2, 2, 4, and 3, 8. So those are my starting points. I'm going to use all 4 of them again. Right there. 1, 2, 2, 4, and 3, 8. Same parent function is there, so I didn't have to think too hard about this starting information. My transformations are a dilation of 2. So now instead of cutting everything in half, everything's going to get multiplied by 2. So this is going to be a stretch. This graph is going to be twice as tall. And I have this plus 2 in the exponent, so I have a horizontal shift. And it's plus 2, so I'm moving 2 in the negative direction, so 2 to the left. Again, order of operations tells us multiplication before addition. So I have to do the dilations first, and then I'll shift things over. So rather than having a y value of 1 here, 1 times 2 is 2. So now my intercept is up here at 2. This had a y value of 2, that got doubled to 4. This had a y value of 4, that got doubled to 8. And this had a y value of 8, so that's now up at 16. It's off my graph. I'm not going to worry about it. And it also got shifted over 2. So now I'm going to take each of these points and shift it over 2. I'm doing this in steps because it just makes it a little bit easier. So now my asymptote didn't move, and these 3 points are the ones I need to draw my graph. Last example, our parent function here is a base of 4. So we're looking at 0, 1, and that parent function gives me these points. Same ones as up here in number 3. The transformations to this graph are a dilation of 3, which means it's stretching our graph. We have a plus 1 in our exponent, so that is a horizontal shift in the negative direction of 1. And we have a minus 1 on the end, so that is a vertical shift down 4. This means my asymptote is also going to be going down 4. I'm going to go ahead and draw this in here. Going a little fast on this one because the bell's about to ring for first period. All right, so our original graph was at 0, 1, 1, 4, and then 2, 16. So I really only have 2 points to go off of again. Each of these got multiplied by 3 for their y values. So instead of being at 1, this is now up at 3. And instead of being at 4, this is actually now off my graph, but I'm still going to graph it. It's going to be up here at 12. And now I'm going to do my shifts. So I'm going horizontally 1 and then down 4. So this one's back on the graph now. And then horizontally 1 and down 4. So I only have those 2 points to go off of because when your base is 4, it grows, whoopsies, grows so fast. Oh, nope. Get up there to 8. There we go. And that is our final graph.